the long version paper. The author is back here. So this will be the last full paper. The title is VPath, two-factor authentication with hands vibration response to unlock your phone. And it will be presented by Zhang.
Yes, okay, thank you. Thanks to Chair. Okay, my name is Zhang. I'm a faculty member with SUNY Buffalo, University of Buffalo. I'm currently, on sabbatical leave, so that's all why I have another, affiliation. This work was done by my student, Seokmin Choi, and unfortunately, he has some visa issue. He cannot come, so I will present this work on behalf of Seokmin. And we know that right now, the biometrics and authentication has been available in our daily life and for all those computers and devices, smartphones. And we have used the biometrics authentication extensively in the real world. But the problem is given the potential, the security vulnerability, and people realize that using one single authentication tool is not reliable. That's the reason in more recent few years, and all of our authentication come to the two-factor. So just like we want to enforce a double check to make sure that the system is securely protected. And for the two-factor authentication, the most common way just combine different modalities. So including what you know and what you have and who you are. So for example, what you know is like the password. Password you set and what you have, which means that like the app, the mobile app, the tokens, and who you are, including the biometrics. So the most common two-factor authentication, such as the password plus mobile app, we have used in our daily life. For example, every time when you log in the website, they ask you to require the Do Mobile or the Google Authenticator app. You have to grab your phone to do the second factor authentication. And also another combination researchers have explored the password plus biometrics. For example, they want to use different sensing modality for the facial recognition using the camera as well as the acoustic. Acoustic sensing, different sensing modality for the same facial recognition. And also for the keyboard, and they want to use your password plus the Wi-Fi sensed the password. Basically, it's still the same thing, but try to use the different sensing modalities. But the problem is, unfortunately, for those two-factor authentication, they rely on two different devices and also separate procedures. Sometimes you feel that is unreliable and also is very annoying. So for example, sometimes when I don't have my phone nearby and I try to find it, where is it in order to access the dual mobile app or authenticator app. So what we want is, can we find some dual-factor authentication that can smoothly integrate all different things together in the same process? That's what we consider. So many researchers has observed that the vibration generated from the hand is attenuated all the way through the wrist. Specifically, the hand's neuromuscular systems result in this attenuation, where different users have a unique system. That's why sometimes when you grab your phone, you can feel that different persons have different way to grab the same phone, and just that is because you have different size of the hand, you have the thickness of the palm, and you have the pressure to grab the phones. For some people, they have a smaller hands, and someone have a larger one. So you will enforce the hand on the smartphone. That's in different way. And more importantly, the neuromuscular system of your arm and your hand will conduct the vibration in a different way. That will cause the different attenuation. So when the user grabs the phone, those occur skin deformation and compression that attenuates and transmits the vibration signal further towards the arm. So the user typing habits and the grabbing behavior is also different from each individual. So what we try to do is we want to take advantage that, okay, so you need to input the passcode. You need to input the passcode on the smartphone, but at the same time, those vibration, those changes, those motions, they will be transmitted through your hand to the wrist area, and that will be captured by your smartwatch. This is the fundamental idea we want to achieve. And inspired by this observation, we propose a true simultaneous two-factor authentication system called the VPath. And that used the vibration signal capture the uniqueness of the user's hand, the user hand's neuromuscular systems. And when the user types in the passcode, the VibPass capture the vibration signal both from the smartwatch and the smartphone, that which the user hand's uniqueness function as a second factor. So your password will still use that as the primary factor, and but this response, this vibration attenuation response, will work as a second factor. So this is the way we want to do that. If someone may ask a question, okay, if you want to use the vibration, why don't you directly use the IMU sensor from the smartphone and you have to rely on the other one? The reason for that is because when you hold the smartphone, you may have different motions. And so in this way, compared to the hand motions, the phone vibration is very minimum, it's negligible. So what we want is, but the hand motion will result in the motion from both the hand side and the wrist side. We want to consider the IMU signal from both parts, and we calculate the differential between those two signals. The difference will reflect the true mapping response function, the pathway from your hand to the wrist. This is the fundamental idea why we do this. And we can see that initially, if we only consider the raw IMU sensor, and basically we cannot tell any difference from this picture. We cannot tell any difference here. But when we consider the difference between the hand and the wrist, that is the unique transmission path, from the hand palm, from palm to the wrist, and we'll see that we will have very clear distinguishable patterns for those for different passcode patterns. So in the experiments, and we used Samsung and Google phones, and we used the Samsung watch, and we have self-developed apps to record the signal, and we recruit 50 participants, and for each participant, we have 50 times for each passcode. We try to create some common passcode from a simpler one to the more complicated one, and 2 separate sessions. This is our experiments. And we can see that the authentication performance, overall the authentication performance is pretty good, and we can, the VibPass can achieve around 98% accuracy on average. The right figure, we can show that on the different phones, the Google phones show a slightly worse performance. The reason for that is the phone is larger. The phone is larger. For some participants, they don't feel very comfortable, especially for the female participant, they don't feel very comfortable to grab a large phone. That causes some, performance degradation. So for the reason, and the reason why we didn't use different smartwatches in this study is because the watch mainly function as a vibration signal receiver, and when the attenuated vibration signal are passed through the hand to the wrist. So we believe the impact of using different watch is less significant than using the different phones, because the phone, when you type the passcode on the phone, that you will cause the vibration and the motion of the phone is more dramatic and more significant compared to the difference of the smartwatch to receive the attenuated, vibration signals. And this is robust evaluation. We have different motions, and the user have different motions, try to do that to see how it works. Obviously, when you are walking and swinging, and the accuracy will be lower than Europe, but this is unsurprising, that because when you are walking, sometimes it's not quite often that when you try to press your passcode and you work very fast. This is not very common scenario. Normally we just stop and try to unlock your phone by typing the passcode. And the conclusion, in this study, we propose a true simultaneous 2-factor authentication system called VibPass, which can understand users' hand neuromuscular systems through the touch behavior from off-the-shelf smart devices. And compared with the existing solution, VibPass possesses a great potential to be employed in future, and smart device and more secure and convenient 2-factor authentication system, because there is no actual actions the user need to do. Is the user just to do one thing, is type the passcode on the phone, and the second factor authentication will be done at the same time and also in a more secure way, because there is no way to attack and try to discover the neuromuscular pattern hidden beside the way is utilized the inside vibration. And this is more secure as the second factor. All right, yeah, that's all my talk, and thank you so much for your attention.
Thank you very much. We are going to switch to the straight away to the remaining two short presentations. Can you please hold on to your question? We'll have a panel session. So can I please invite the author of the short note, user authentication method for hearables, using sound leakage signals, that will be presented by Takashi. So the podium is yours.
Hello, my name is Takashi Amesaka. I'm postdoc researcher at Keio University in Japan. So I will present the